All right. Are we happy to go? Hope so. All right. Well, hello, everyone. I'm Matteo Carlini. Thanks for joining today. I'm here with Shebu Kuriakose, my colleague. We are both the chairman of the project for the TrustedFirmware.org community project. And today we are going to give you an update on the news and the latest things that are happening in the context of the Trusted Firmware community project. So first of all, usual introduction, what the project is. So Trusted Firmware is an open governance community project for the entire secure software development in a collaborative way. And I'm going to stress on the entire secure software collection because, so the name says Trusted Firmware, and it originally, kicked off as a TFA and TFM project, so Trusted Firmware for the A-class devices and for the M-class devices. But over time, it acquired and we were joined by other projects to provide a reference implementation for a trusted execution environment, for security libraries, and now also for security services. So really, it's becoming a complete reference implementation of the entire secure software space on ARM devices. It's all open source. The code is all released under BSD free clause permissive license. We have a very advanced OpenCI, which Shebu is going to describe later on in the project. And we are regularly running open forums, open chats, there are open mailing lists in which all the main topics are discussed across all the projects. So I usually pick up some data, some statistics to argument on the importance of collaboration. So this time around, the data that we picked up it was Shebu's idea, thanks Shebu, by the way, it was on the number of reported security vulnerabilities which have been addressed by all the projects within the TrustedFirmware.org community. So that means all the security fixes that all the projects had to develop, investigate, analyze, apply, test, and then validate, and then tag and release in one of the open source releases for all the number of the security issues that either we found or we were reported by security researchers or by the community. So you can see it's a constant number. And in the last 12 to 15 months, we have something like 33, so 33 vulnerabilities, which counts more than 2 per month, okay? So if we consider this number, and if we consider the effort that we have to spend in a collaborative way, with our security experts to, as I said, do all the initial analysis and then prepare the proper fix and apply it. So you can easily see that if these efforts have to be multiplied in a downstream way by every single different downstream implementation of TFA by our partners or TFM, or OPT, or all the other security libraries, that becomes highly inefficient. It becomes not scalable because this effort will have to be repeated every time on every single downstream implementation. So this clearly highlights how important it is to put together all the brains, all the expertise, all the skill set, and fix our problems, in this case, security vulnerabilities, provide a stable fix and maintain that, because the maintenance is also done in a collaborative way, and doing that all collaboratively, all in the common platform that is TrustedFirmware.org. That is really achieving the security by scale that we are really aiming for. So I'm going to announce some news in the project. The first news is 2 new companies that are joining the current roster of company members. So above you see the current members, and we were recently joined by NXM Labs, an open mobile platform. That was late 2020. We published a press release to announce those 2 companies joining the Trusted Firmware family. And we are pleased to have them joining both the board and the TSC, which are the 2 main governing bodies and entities that runs the project. So the board of directors is the entity which governs the strategic direction and the investment decisions of the Trusted Firmware projects. The technical steering committee is the governing body which discuss and decides on the technical matters for all the projects part of the community. So now let me go a bit in deep into one of the latest release for a couple of projects part of Trusted Firmware, which is TFA and the combined Hafnium. The release was done in November. It was a major 2.4 release, and it was important, a stepping stone, because it was the very first release of Hafnium as a reference secure partition manager for the secure EL2 ARM virtualization extension. This is the first Linaro Connect in which I had the opportunity to announce it, but the release is out since November. The next slide will explain more the use case that we enable with that. And I'm just going to point you to another talk later this week, which explains how we are able to run OPT as a secure EL1 partition on top of Hafnium running at SEL2. But before we move to that and deep dive on that use case, the 2.4 TFA release also saw other features which were promoted upstream, the complete set of the 8.6 architecture feature support from the A-class architecture, measure boot support in TFA, support for a split dual root chain of trust in the boot chain, and then the usual bunch of new platforms. So there are some ARM platforms, the ARM Morello board and the ARM Total Compute T0 platform, which are respectively a research board for the capabilities architecture, which is a research program run by ARM and the UK government, and the Total Compute platform, which is a complete mobile software stack running an Android system on top. And then we've got the usual bunch of partner boards. We enable more than 10 partners in the last release. Now, I promised a deep dive on the use case for Hafnium, so here we go. The main use case is really enabling isolation through virtualization in the secure world. So what do I mean by that? Well, we mean basically enabling what you can call like secure VMs, so VMs that runs in the secure world. We call them secure partitions in the software architecture, which are isolated partition, which only sees a limited set of system resources, which is defined by the underlying entity, by Hafnium, and two or more partitions are isolated one another. That means that it allows our partners to deploy different type of services into one of these partitions, and these services can be mutually distrusting. One can be a full, complete trusted OS or a trusted execution environment. Another one can be a trusted services, a secure services. It doesn't matter. They are independent one another. And the other key point, which this slide is trying to capture, is also the effort around the standardization of the interfaces at the boundary level. So if you see all the blocks with FFA, we went through a lot of effort in the past months for enabling the firmware framework for A-class FFA. Spec is a specification from ARM which defines how the normal world can call for secure services into the secure world and how all the message passing and all the resource allocation happens in the secure world. By the adoption and the standardization of these interfaces, we aim to really defragment and clean up the TCB on the ARM devices ecosystem. And the final use case that we are enabling, if you see the dotted lines on the EL3 SEL2, but also on the normal world. So with the introduction of secure EL2, basically EL3 and SEL2, so the highest privileged pieces of software or firmware that runs on your devices, are protected from possibly compromised software which runs in the secure partitions. And so are the normal world hypervisors or kernel or applications. So how's that? In the previous situation, if you have a compromised software running in a partition, the trusted application gets compromised, the malicious software gets deployed on the secure world. So in a usual scenario, this malicious code would be able to easily jump from SEL1 down to EL3 without the protection of SEL2 in a scenario with no SEL2 in the picture. But with SEL2, that malicious code is confined in that single partition, and there it remains. So it doesn't go around and poke in your system. It just remains confined there. And that's really the key point and the key message that I want to convey around the isolation which is achieved by this new software architecture. Few ongoing developments for Hafnium and Trusted Firmware A. Regarding Hafnium, I can point you to the specific deep dive call, which is happening on Thursday by our Hafnium maintainers. There are activities ongoing for hardening Hafnium, introducing support for the pointer authentication extension and BTI. There is a new driver for the SMMU ARM system IP, and we are enabling support for the Neon and SV registers in secure partitions. There is work ongoing around power management and interrupts handling. And we're also enabling, because for now we are able to demonstrate OpT as a full trusted OS running in a secure partition. But we are also working to enable a scenario with only secure L0 partitions, which runs secure and trusted services. So that means services which do not have to rely necessarily on a trusted OS, but can be independent and can sit on top of Hafnium independently. Other activities ongoing, support for the ARM 8.7 architecture features, which has been published by ARM last September. There is a new IP for the automotive market, a new interrupt controller, GIG 600 Automotive Edition, which adds a few functionalities relevant for the automotive ecosystem that we are enabling in TFA. And then there are other 3 talks, which I'm pointing you to during this week. One is around the standardization effort on the firmware update. And there is a specification work going on, which is going to be explained in this talk. And TFA will provide, again, stepping stone for the implementation. There's a talk about the firmware configuration framework, which is a way to dynamically configure the firmware with platform-specific information that are not hard-coded, but that are passed dynamically throughout different bootloader stages. And then finally, I spoke about Measure Boot, so there is another deep dive presentation on Measure Boot later this week on Thursday. And with that, I'm going to pass on to Shebu.
Hi, everyone. Thanks, Matthew. So I'm going to just kick off by going back in history. So when TrustedFirmware.org was launched back in 2018, as Matthew was saying, we just had 2 projects, Trusted Firmware A and M. In 2019, Linaro transferred the ownership of OpT into TrustedFirmware.org, and in 2020, we had MBTLS and Hafnium also joining the Trusted Firmware family. All these firmware components have together enabled Trusted Firmware to provide a high-quality reference secure world implementation for both Cortex-A and Cortex-M platforms. Today, we are very glad to announce the newest arrival to the project portfolio through Trusted Services. Trusted Services, again, complements the existing Trusted Firmware.org projects in increasing the capabilities of the reference secure world implementations. Now let's look at Trusted Services very briefly. Trusted Services at a very high level can be considered as a framework to develop, test, and deploy secure services on a wide variety of isolated processing environment. By isolated processing environment, it can be a virtual machine running over a hypervisor. It can be a trusted application in a trusted execution environment, or it can be a separate secure core that is providing root of trust to the entire platform. As you can see in this diagram, these applications can call into the trusted services using a client-server model, and any application call into these trusted services using an RPC mechanism, using a defined service access protocol that is defined on a per service basis. As a starting point, Trusted Services is providing secure services exposing the same PSA functional APIs for cryptography, storage, and attestation, similar to what we have in Trusted Firmware M project today. And our initial reference implementation as you can see at the bottom of this slide, is going to be based on OpT running as a secure EL1 trusted operating system, with these trusted services running as secure partitions over OpT, enabling normal world Linux-based applications to call into these secure services and avail secure services. Again, I would encourage you to watch a deep dive into trusted services by Julian Hall later today. Moving on to some of our other project activities, starting with Trusted Firmware M. As the project has matured over the last couple of years, now we have moved into a release model of releasing every 4 months. We are in the process of getting ready for the next TFM 1.3 release, which is planned to happen in early. This is going to come with an exciting set of new features, including a new PSA firmware update service. The profile work gets completed with enabling profile large, and the initial enablement for the latest PSA firmware framework 1.1 version. And this just adds to the set of functionality that was there in 1.2 with level 3 isolation. We had done work around some generic software mitigations to mitigate against physical attacks, etc. TFM is also now enabled on a wide variety of silicon platforms, as listed here. And looking ahead, we have also started enabling TFM for the latest Cortex-M CPU, that's Cortex-M55, using the Core Stone 300 reference platform. And over the last several months, now TFM has got a good level of integration with some of the popular RTOSes like EmbedOS, FreeRTOS, and Sapphire as well. Moving on to MBTLS. So MBTLS now marks 1 year since it was transferred in as a trustedfirmware.org community project. Again, we are seeing a lot of contributions coming into this project, so thanks for all that. These are the 3 major areas of work that we are focusing on at the moment. MBTLS 3.0, which is going to be a major release, which will have a lot of deprecated APIs removed, cleaning up of obsolete features, etc., which we are planning to release by middle of 2021. TLS 1.3, we have an initial prototype implementation, which is getting cleaned up and being upstreamed functionality by functionality into MBTLS. So we would have an initial level of support for TLS 1.3 later on in this year. One of the major focus area for the project as a whole over the years have been PSA crypto implementation. So we have made great progress in terms of implementing the PSA crypto APIs as the user-facing APIs that can be used by TLS and other security use cases. And over the last 3 to 6 months, now we have defined a PSA crypto driver interface that enables MBTLS or PSA crypto implementations to secure elements and accelerators. So quite a lot of progress in this project as well. Now, if we look at some of the other community activities that has been happening in the recent months, we have got the TFA and TFM technical forums that was kicked off around a year back. So these are calls where we discuss a lot of new design ideas, get feedback from the community. So this is a bi-weekly forum, which I would encourage all of you to join. There are quite a lot of discussions happening in these forums. With MBTLS coming on to tf.org, we have arranged a virtual workshop back in November, which was highly successful, attended by around 75 people from around the globe. There were technical talks on the project on a wide variety of topics, including areas like how can people contribute easily to MBTLS project, become reviewers and maintainers. So again, these are all attempts to expand the outreach and the community participation around all the trustedfirmware.org projects. Moving on, so as Matthew was telling in the beginning of the presentation, there are a lot of activities around open code development, reviews, technical steering committees. This is all behind the idea that at the heart of trustedfirmware.org is collaborative development. One important pillar of this collaborative development is, of course, to expand the technical leadership of some of these projects to reach beyond ARM engineers. TFA had kicked off this by having maintainers outside ARM from last year. And today, we are very proud to let you know that even some of the other projects is taking a similar route. So Hafnium, its maintainers list, so that has got maintainers from Google, Linaro, and ARM. For MBTLS also, we are expanding the review and maintainership list with Stephen Kurman from Silicon Labs being appointed as one of the official reviewers. And very recently, actually, this month, Trusted Firmware M got its first non-ARM maintainer. So Chris Brand has kindly accepted the nomination to become the Trusted Firmware M maintainer as well. Moving to another topic on open test system. So one of the biggest investment that this community project has done over the last 12 to 18 months is to develop an open test system for all the constraint projects. This is with the sole aim of increasing or making the collaborative development easier for the community. So here the motto as shown in this diagram is every Trusted Firmware patch that gets submitted in turn triggers a Jenkins job, gets built on all the supported upstream platforms, and those built artifacts are then tested on a variety of platforms as well. So we started this journey around 18 months back. And again, a great milestone that we've achieved in the recent weeks is both Trusted Firmware M and A is moving to a model where every commit of these projects are now being gated by the open test system. So these results and the maintainer feedbacks would be the key things to decide submission or merging of these patches. And we are also looking at expanding the open test system to support all the upstream platforms from the members as well. Again, I would suggest you to have a look at ci.trustedfirmware.org, where the open test system front end is getting hosted, and you can see all the tests that's happening today. Finally, I'd like to close by quickly looking at what are all the upcoming topics, looking slightly ahead into the future. OpenCI still remains a big focus area for trustedfirmware.org. We have now got a good baseline with Trusted Firmware M and A. We want to expand it very soon to have more member platforms, but also cover other projects. MBTLS is going to also support OpenCI. Again, a project with a lot of contribution. So we want to make sure that when people makes contributions to this project, they can easily see the test results. If there are problems, they can fix and resubmit the patches. Trusted Firmware community activities, we've got the technical forums going in full steam, but we want to have more evangelization of our community efforts to make people aware of what these projects intend to do, bring about more developers from across the board to support the community project. As ARM evolves its architecture in the A, R, and M space, these projects would be one of the first projects to get those enablements. So in the Cortex-M space, as I said in the TFM slides, we've started enabling Trusted Firmware M with some of the 8.1 M architectural features. Similarly with R64, also there'll be enablements in the relevant Trusted Firmware projects. And in the new architectural evolutions that ARM will be doing, those enablements will also be supported in the projects. Finally, long-term stable releases is something that the community has been talking about for a while now. Today, only MBTLS supports LTS releases. So something that we as a board, technical steering committee, and the community will be discussing in the coming months is the viability of having long-term stable releases for some of the constant projects. Again, an excited roadmap. Would encourage you to be part of this journey as well. Thank you very much for listening in to this short talk. Please do visit trustedfirmware.org, subscribe to the mailing list, and please do attend all our bi-weekly technical forums. Thank you.